Hi everyone. Sorry for the video. I know we don't really like to do the video notes and half of the class won't even watch them, but there are a couple of things that I wanted you to see that we need those last two examples from the 7-3 notes to kind of illustrate. So the first set of things I want to show you is actually in number 2, when we're finding multiple sides of the same triangle, kind of what I want you to do as you approach this. So first thing, and one thing that's weird with this problem, you can pick either angle, the 54 or the 36, as your reference. It literally does not matter. So whichever one you like better, I'm just going to use the 36 here as my reference. So the first one I'm going to do is this A, because it's first in the list. That's the only reason. You could do either one first. But I look at side A, and I see that it's across from the 36 I chose. So this is my opposite side. Then I remember I look for the other side that we know, and we know the 30. That's across from the right angle, so that's our hypotenuse. Then we think through our mnemonic device. We need opposite and hypotenuse, so this is going to be sine, just like number 1 was. Okay, good deal so far. So we've worked through first 3 steps, maybe 4, I don't remember. Oh, 3. Now we're writing 4. So to write our equation, sine of, I decided to use 36, so that's what's going to fill in here, equals, the opposite's what I'm looking for, that's the A, and then the hypotenuse is the 30 that we knew. So this one, if you chose the 36 and you're finding A first, it's going to work out a lot like that first one did, where we're going to multiply both sides by 30. You do need your scientific calculators. Obviously, if you're in class, you can borrow my yellow ones, and that's totally fine. But as we do this, we're going to multiply by 30. So 30 times the sine of 36 degrees equals A. You go to your calculator, sine of 36 times 30, or 30 times 36, and we should get 17.6 as our answer. Okay, then you have to go do the second one, and this is why I actually wanted to do this problem. Not for A, because that works out a lot like number 1 did. But when you go to find the next one, you have some options, but what I really want you to do is use trigonometry again. So for this second one, use trig again. So we'll kind of pause and reset and just do a new little problem. Now we don't have to reset everything. Like we can keep the reference angle the same if you want to. It's just instead of finding A, I don't care so much about A now. I want to find B. B is what I'm looking for, and that's the adjacent side to my 36. So the other thing that changes here, now that we're looking for a different side, we're going to need a different ratio. This will be the cosine. Still of 36. I don't have to switch to the other angle just because it's there. And now we're finding B, and that'll be over, still the same 30. Hypotenuse is the same as it was. So as far as your process goes now, we're still going to multiply both sides. So that's about the same. We should get a different answer, though, because this was a different ratio. The cosine of 36 is different than the sine of 36. And this should come out to 24.27, but we're going to round that to 24.3. So theoretically, some of you are going to want to use Pythagorean theorem once you have this first answer, because then you've got two sides. You have the 30, you have the 17.6. But please don't do that, because this 17.6 is a rounded value. And we should never calculate with rounded values. So anytime you're finding a second part of the same example, always go back to the original answers, what you were given, the whole numbers, right? Go back to whole numbers, go back to what you were given to reset to make sure this answer is perfect. Okay, that's what I wanted you to see on number 2. Now number 3, we don't have to do this whole thing, but I do need to show you how the algebra goes on this because it is a little different than examples 1 and 2. Okay, again, I'm going to start with x because it's just the top. So I know I'm going to need to find this side. My reference angle I'll just use the 55 since it's already calculated for us. The x side that we want is across from the right angle, so this is the hypotenuse. We'll definitely have to use hypotenuse. And then the side that we know is this 7. That's opposite. And it looks like we're starting with sine again, so that's convenient, I guess. So as we write this equation, hopefully you guys are getting comfortable with this. Sine of 55 is opposite 7 over over hypotenuse, which is our x. Okay, guys, there is a huge difference between the way this set up and the way that the other ones have set up. Look, our unknown number is at the bottom. Here, our unknowns were at the top. When we go to try and get this by itself, when we try to do our algebra to get that fraction to go away, we were multiplying by the number that we had, right? But it wasn't because that was the number. It was because it was in the denominator. Anytime you have a fraction in your equation and you want it to go away, you have to multiply by the denominator. So this time, we're going to be multiplying by x. So those x's on the right-hand side will cancel. That's why we multiply by the denominator, because it's divide by x and then multiply by x. It cancels. So now we have x times the sine of 55 degrees equaling 7. So in 1 and 2, all we needed was that multiplying step, and then our variable was by itself. We were ready to go to the calculator. In this case, though, we did our multiplication. Okay, great. But our variable's not by itself. We still have this sine of 55 with it. So we have one more step. Anytime your unknown is in your denominator, so the hypotenuse, always in the denominator, or if you end up doing tangent and you're looking for the adjacent side. Anytime your denominator is your unknown, you're going to end up with 2 algebra steps, not just 1, because we need to get rid of this sine of 55. Since it's multiplying by x, I am going to use division to cancel it out. So on the left, they'll cancel, leaving me with x by itself over there, which is perfect. And then the expression we're going to type in our calculator is going to be 7 divided by the sine of 55. So you go to your calculator, you hit 7, you hit divide. Even though it doesn't look like a fraction on most of your calculators, it'll look like just a division symbol. And then sine 55, and you should get 8.545, etc., which of course we will round to 8.5. So as far as the actual calculator work, once you've done your algebra, once you've set up your equation, done your algebra, there are 2 things that you might be doing in your calculator. You might be multiplying like we did here. There was multiplication that we put in the calculator. Multiplication, multiplication. So if your unknown is in your numerator, yes, you will multiply whatever number you had by your trigonometry function, your cosine of 36 or sine of 55 or whatever. But if your unknown is in the denominator, what you ultimately end up putting in the calculator is a division problem. It's your number divided by the trigonometry part of it. So I know some of you are going to try to take shortcuts. Just please think through why you're doing what you're doing. I would much rather you write out the equations. Like, I would love to actually see this part. That way I can help you if you get your answer wrong. But for right now, as long as we're just getting some answers, I think that'll be a good start. So that's finishing up the 7-3 notes. Just a summary if you didn't read through the whole Google post for today. We were originally supposed to actually start 7-4 today, right? The next one. We're just going to push that to Monday. So there's not going to be a vocab quiz on Monday. We're just going to start 7-4 notes, do some work time on that practice, and then you can, during that work time, if you have questions on all of this, you can ask me then. We can work on it. We can schedule advisory time, whatever you need to do. So if y'all have any questions, send me an email. If you're able to send me a picture of your work with that email, that's even better because then I can really help you. But other than that, have a great day, enjoy your weekend, and I'll see you on Monday.